This is the Integrated Math 1, Chapter 1 note page on functions. So in box number 1, they want you to take the 4 and plug it into the function machine. So you're going to take the 4 and you're going to square it. Make sure you put in parentheses because even if it's a negative number, you're going to need to square it. So 4 squared is 16, and then 16 minus 9 is 7. So you can either write the answer like this, the function of 4 is 7, or you can write it as a point for 7. In box number 2, it says a function is an equation in which each input produces exactly one output. So in the first box, we have something that does, yes, it does produce a function, because each point input, it produces exactly one output. But in the second box, you're going to notice that when you put in a 1, you get a 3, and when you put in a 1, you get in a 5. That's like our soda machine kicking out a Pepsi and a spray. All right. On the right, I drew a picture of a graph that would be a function. That is a parabola, and yes, it is a function. In box number 3A, there's a tile pattern. In figure 0, there's just 1. In figure 1, there are 5 tiles. In figure 2, there are 9 tiles. So you need to draw the third figure and the fourth figure. And then in the box next to it, in box 3B, you're going to fill in the chart, come up with the equation, and then they just want you to say, what does the X represent? Well, the X represents the pattern figure. What figure number are we on? And what does the Y represent? It represents the number of tiles. Jumping down to number 4, you're going to follow the order of operations. So please excuse my dear Aunt Sally, or parentheses, exponents, multiplication and division, addition and subtraction. So for this problem right here, the first thing I did was I multiplied the 5 times 2 to get the 10. And I subtracted 7 minus 9, which is negative 2. Then for the next step, I simplified the 7 minus 10, which is negative 3. And I squared the negative 2, which is 4. Then I took the absolute value of negative 3, which is 3. And then I multiplied 3 times 3, which is 9. And I get the answer of 9/4. In box number 5, it says list the domain and range up to the right. So all of the domain is going to be all real numbers, because this parabola is going to extend forever this direction and extend forever this direction. You could also write negative infinity to positive infinity, or you can write all real numbers. Range, the numbers that will be produced. So when you plug in, the lowest number it could ever be is negative 3, so it's going to be greater than or equal to negative 3. In box number 6, you're going to use your exponent rule. So if you have x to the third times x to the fourth, you're going to add those exponents and you'll get 7. So the generalized rule is x. As long as that base is the same, you're going to add the exponents. For division, you're going to subtract. So when you take 6 minus 4, you get x squared. We're going to generalize the rule. This should say a and b, so it's going to be x to the a minus b. X to the 0 is always 1. And then the last one is a power to a power. So you're going to multiply those exponents. So you should add the x to the 3 minus 2, which is 6. And then the generalized rule for a power to power is a times b. For box number 7, we're going to add the 2 fractions. So I had to get common denominators. So 2 goes into 10. 5 times 1 is 5. 5 goes into 10 twice. 2 times 3 is 6. So now that the denominators are the same, you rewrite it, and you add the 5 and the 6, and you get 11 tenths. Now this one should be subtraction. So same thing, we need to get common denominators, and then we're going to subtract. So 5 minus 6 is negative 1, so it should be negative 1/10. Multiplying fractions, you're going to just multiply straight across. 1 times 3 is 3, 2 times 5 is 10. If ever you can reduce this, you obviously want to reduce. And then for division of fractions, you want to use the invert and multiply rule. So you're going to flip that second fraction to 5/3, and then instead of dividing, you're going to multiply. So 1 times 5 is 5, and 2 times 3 is 6. And as with multiplication, if you can reduce, then you're going to want to reduce.